Welcome to Lectures by Aparna. Today let's discuss about stacks. So what is a stack? It is a set of memory locations which are used for a particular purpose. So what is that purpose? Suppose we are having register pair BC. This is the register pair BC in 8085. So suppose we want this BC register pair. So let the content in it be 832A. So if I need this register for some other purpose, so I have to shift the content in this register pair to some other location, and then I can use this BC for whatever purpose I need it, and then I can take back these contents after the use is over. So for that operation we use set of memory locations called stack. So for that, to push these contents to the stack we use the instruction push, and to take it back from the stack we use the instruction pop. So let's see how a stack will look like. So this is how a stack will look like. These are the memory locations and this is the address of the memory location. Let these be the contents that are present in the stack. Now, if I am having the register pair BC, let the content in register pair BC be 83 and 2A. So what is happening? This is the stack top. Okay. So stack top means it is the portion where the last data is saved in the stack. So the address of the stack top, which is in this case 2605, this will be stored in a particular register. That is called the stack pointer. So in stack pointer this address will be stored, that is 2605. And now the next available location in the stack is this. This is the next available location. So what is happening after I execute the push B instruction? Push B means that I have to push the content from BC register pair to the stack. So what is happening? This 83 from B will be put into this memory location, and then this 2A will be put to the next memory location. So now the new content that is present in the stack pointer. So this is the new stack top, and the new content that is present in the stack pointer, that will be 2603, and then the next this will be the next available memory location. Okay, so this much will be happening in the case when push operation is executed. So now I am having the stack like this, where the contents 83 and 2A is put into the stack. So the stack pointer now contains 2603. That is the address of the stack top. Now what happens if I need to take back these contents to register B and register C? So after executing the push instruction, this register B and register C will be free. So now I can use these registers for whatever purpose, and then after that operation is completed, now I have to take back these contents back to register B and register C. So to take it back we use the instruction pop B, that is popping these contents back to these registers. So once I execute pop B instruction, what is happening? will be taken back to register C. So 2A will come back here, and then this A3 it will be taken back to register B. So now I get back A3 and 2A. So now what will be the new stack pointer? See, new stack pointer will be having the address 2605. 2605 will be the address that will be present in the new stack pointer after executing pop B instruction. So the principle that is being followed here is last in, first out. Last in, first out. That is the data that came last will be taken out first. That is last in, first out principle. So this is the concept of stacks. So what is a subroutine? Subroutine is a small sequence of instructions that are used to perform a particular specific task. So this concept of subroutines is used to avoid the repetition of small programs in the main program. So there will be a main program. Suppose this is a main program. See, there are many instructions in it. And suppose an instruction called subroutine A, sub A, comes in the main program. So this subroutine sub A will be written in a particular memory location, and it will be a small program that will be written separately and stored in the memory, and that will be called when it is needed. So this is the subroutine A, which is named sub A, and when it is called, this program will be executed. So the instruction that is used to call a subroutine is called call instruction, call. And from the subroutine, if you want to return to the main program, you use the instruction RET, which means return instruction. So let's see what is happening. So the main program will be executed line by line, and when it reaches this line, what is happening? The instruction says that it has to call the subroutine A. So from here, the next instruction will be starting from this line. First instruction of subroutine A, sub A. So this will be executed, and in the last line of the subroutine, it will be RET, which means that from here it has to return back to the main program, and then this instruction will start executing. And now if somewhere here you are calling the sub A again using the call instruction, what is happening? After you call the sub A again, it goes to this first instruction of the sub A, and then this will be executed, and when it comes to return, it will come back to the main program. So likewise, you can repeat this program in the main program. You just have to add this instruction call with the name of the subroutine. Now subroutine need to be written only once. After that, the programmer can call it from any point in the main program. Now let's see what's happening in the program counter. Program counter, when you call a subroutine. Say suppose the memory location is like this: 143014311432, and the subroutine is written in the memory locations, say 2392, 2393, 2394, 2395, 2396 likewise. So what is happening here? What is a program counter? Program counter is a 16-bit register that is storing the address of the next instruction that is to be executed. So this program counter will hold the address of next instruction that has to be executed. So when it reaches this instruction, the content in the program counter will be 1432, which is the address of the next instruction it has to execute. But actually it is going to the subroutine. So when it is going to the subroutine, what is happening? You have to save this address onto a stack. So I am transferring this 1414 into the stack and then 32 into the stack. Now this will be free. Now I have to load the memory location 2392 into this program counter. This is the address of the first instruction in the subroutine. So the control will be transferred to the first instruction of the subroutine and this will be executed, and when it reaches RET, what is happening? Say it is having 2396 now in the program counter. Now from here it has to go back to 1432. So this stored in the stack, that the address will be taken back to the program counter. So this 14 will be taken back and this 32 will be taken back. So what happens after return instruction? This program will start executing from here, since the address of the next instruction is 1432. Likewise, you can call a subroutine, and while calling a subroutine, the program counter will be updated like this. That is storing the content that is present into a stack, and then it will store the address of the subroutine into the program counter. Subroutine will be executed, and when it reaches the return instruction, this address that is stored in the stack, that will be popped back into the program counter, and then it will start executing from the next instruction in the main program. So this is how subroutines are called in the main program. If this video has helped you, please do subscribe to my channel. Thank you.